Testing, testing. No wonder I couldn't hear myself. Alright, there we go. Alright. I was just saying that, you know, our viewership numbers are even lower than they usually are. Ah! There we go. Cool. Yep, we've fixed the problem. Ah, uptick. They must have realized I forgot to turn my microphone on and are now filing in. But anyway, yeah, so, how's everybody's weekend? Oh, and before, I know that A8, Assignment 8 hasn't been posted yet. That'll be done sometime today. Sometime this afternoon. So, yeah. I guess, with respect to sort of the general refrain of general announcements, we've got a couple of things that we need to keep track of, etc., etc. In the first place, those of you who are observant observers of the course syllabus may have noticed that this Saturday we are scheduled for our third and final test / midterm. So, I've already got questions about the coverage. So, with respect to the test coverage, I'd say we're gonna go up to about the end of files here. I'm not going to test you on internet, and we're going to leave the file formats stuff for the exam, I think. Basically, everything up to and including some of the more simple file I/O operations. There'll be a question on that asks you to read stuff out of a file, maybe do something to it, that sort of thing. But we're not going to get into like JSONs or anything. Not on this one. That's fair game for the exam, but for the test, we'll just leave that where it is for the time being. So. Hello, Mark. How's it going? Mark is in the chat, everybody. Yeah. So that's that. Cool. The other thing that I just wanted to make an announcement about, even though there hasn't been an announcement on Avenue about it, but it's sort of on my brain at the moment, so I'm just gonna say something about it. Do you guys remember at the beginning of the course? Mark is tired. That is typical Monday. Typical Monday. You guys remember at the beginning of the course how I was saying, okay, J-Hub is acting up. Have we talked to Derek and company about that? Or is that like a general internet problem? So, if you were unable to submit your assignments through Jupyter last night, please get them in through Avenue in fairly short order, please. But yeah, that's kind of the whole reason we have these sort of multiple redundant means of submission, is in case one of them is acting up and the other one is still available normally. But yeah, okay. Anyway, the thing I was saying. You guys might remember at the beginning of the semester, I said that towards the end of the semester, it was entirely possible that I might have to take a couple of days off of doing the, okay. I might have to take a couple of days off of lecturing, in which case the TAs would be filling in on their own channels. You know, in the event that my wife should go into labor because she's right now 9 months, 8 months, 9 months, 8.5, something like that. She's quite pregnant. She's now officially on mat leave, actually. So we're kind of, in our household, expecting any time now. Although, most probably, it'll be a week or two from now. But, you know, just keep in mind that if you suddenly and unexpectedly have to go to one of the TA's YouTube channels to pick up the lecture, there'll be an announcement and all the rest of that. Probably not by me because, I'll be busy with all of that process. But, yeah. Students managed to exceed the daily server limit of 1 million actions. Wow. How? How on earth? Jeez. That doesn't even seem possible. I don't know, maybe someone's just trying to break the server. To your question, Christoph, the exam is going to be formatted precisely like the test. And it's also going to maintain the 24-hour time window. Yes. Yep. Thank you. We're pretty excited. We got all of the stuff ready, more or less, so we're kind of all dressed up with nowhere to go at the moment, but that's kind of the state of the situation in this particular. Well, in order for it to be 1 million actions, it would have to be like 1 million people executing code blocks rather than 1 million lines of code. Like if it were 1 million lines of code executing, that would be much easier to hit. Don't worry too much, guys. It's not like I'm going to be taking the rest of the semester off. For those of you who have never really like gone through the process or anything, it turns out that labor can take, a reasonable amount of time. It's like, that's what I thought, Mark. It can take like a full 24 hours or more than that sometimes, from start to finish. Although like it's very much unlike what you see on television. But you sort of have active labor at the end when the baby is actually being born. And, of course there'll be a period of recovery after that, and, the doctors will want to run some tests to make sure that, the kid's all right and all the rest of it, which, everybody hopes for health. But, essentially, probably it'll be a couple of days that I'm just kind of out, But yeah, it's But I'm not saying I'm taking the rest of the semester off or anything like that, but depending on when it falls, like if it falls on a weekend, then, it's you probably won't miss any lecture at all, but it's not really up to either of us, so. But anyway, we should get to the actual lecture material today. So when we last spoke, we were talking about files. But like Alex, even if everybody in the class submitted the thing 25 times, assuming they were as worried about it as you were, that would still only be 6,250 interactions. So we still have to, to get to 1 million, we'd have to do that 160 times. So, it's on your, it's on your end. I can hear me, and that usually means you can hear me. So, anyway. So, file interaction. This is actually, like, as topics go, I would say, I would put file interaction, it's kind of, I'd say, halfway between the material on, numeric computation and, exception handling. Conceptually speaking, we're kind of in the same territory as exception handling. File I/O is not especially hard or difficult once you understand what a file stream is. Kind of like exception handling isn't particularly hard once you understand what an exception is. However, with a lot of the file I/O type stuff, the devil's in the details. When you actually sit down to write the implementation of whatever problem you're working on with file I/O, that's typically where you end up running into, this is a little bit tricky to implement. It depends on, like, the manner of the question. For your poor humble professor, sometimes setting a test question with respect to file I/O, especially when it involves these file formats, it can be very, the difficulty is not always easy to predict, if that makes sense. Some things that I find to be very easy, sometimes other people find to be very hard, and vice versa. But at any rate, so what is a file stream then? Very quickly, in Python, in Python, as in most other languages that perform permanent memory interaction, you open a file stream in order to interact with some file that's sitting on the hard disk. The file stream itself is information about what file is being accessed, how far along that file is in your reading of it as well. The reason you should think of it as a file stream is because you should think of it as a stream of data that's flowing into your program, and you get to control how quickly that stream of data flows into your program. Remember that when you read stuff in from a file, it will always, always, always be in the form of a string. So if you're reading in data that's in integer or floating point format, or should be in integer or floating point format, you're going to have to perform manual conversion on it in order to get it into whatever file or whatever data type is appropriate for the calculations you wish to perform on it. So that's a good thing to keep in mind. And that also applies for Booleans. So there you go. So in general, the file stream, there are sort of three major operations that you perform on file streams. Number one, you open a file and create a file stream. They are also sometimes called file handles. You read or write however much or whatever information you want from the file stream, and then you have to close the file stream. Closing the file stream is very important. Depending on your operating system will lock other programs out of modifying any file that any other program is currently modifying. Once again, this is like this idea, if you have a document, PDFs are a good idea, a good example of this. If you have a PDF open, you can't rename it, right? In Windows, at least. So if you've got, like, Adobe open and you've got some PDF and you want to rename that PDF to something else, your operating system will tell you you don't have permission to modify the file name, and you have to kind of intuit that that's because the file was open somewhere. The operating system actually locks you out. That's because in order to modify the name of the file, you have to write to that file. or at the very least, you have to write to sort of metadata within the operating system itself, not necessarily in the file itself, but that's kind of neither here nor there. When you close a file, when you close a file stream, what you're doing is you are telling the operating system, I am finished with this file. You may do with it as you please. I no longer have any vested interest in the state of this memory. So this is good. Once again, you open a file in Python with the open function. You must specify the file name, and you specify the mode in which the file is to be opened. This is a relative directory, not absolute, although absolute directory would also work. Yeah, very, very quick and easy. So if we take a look at our very simple file reading Python script right there, Python 3, topic 9.py. There we go. There once was a man from Peru who dreamed he was eating his shoe. He woke with a fright in the dead of the night to find that his dream had come true. There we go, which is, of course, the contents of the file that we specified. Bing, bang, boom. So that's cool. And we got so far inside of last week's lectures. Are the tutorials a week ahead of the lectures? Oh boy. The mic again? Oh boy. Takes me a while to figure it out. Boy, what a face. A face like a slapped arse. There we go. There we go. That's better. Yep. Probably a couple of public test cases for that. Yes. So, when you're in read mode, you've got read, which reads the entire file, and then read line, which reads one line of the file at a time. So, for example, we could do something very easy, a simple modification of this file if we wanted to, for example, insert line numbers. That's one idea that you could, that's one way that you could one use you could have of using readline versus just read the whole thing. Although you could do this with read the whole thing as well. But yeah, so the idea is, gotta increment that bad boy. There you go. So in general, the idea with file I/O is you don't just read something in for the fun of it. The idea is that you're reading in data, performing some transformation of that data, or calculating something from that data, and then that result is what you then work with. That's the point. You are trying to accomplish something. It's too facile to just read a file and display it on the screen, right? Ordinarily, what happens with file I/O is that when you read something in, you want to make some modification to it and then put it back into the file it came from. So we have yet another one of these fun little Python shortcuts. Having done very, very little file I/O so far, we can already see that remembering to close our file handles can be a bit of a pain. fh.close. That's a pain. Why do we need to remember that? That just... Is there some way, Python, that we could just not have to do that? And Python's like, yes, you can use a with statement, and I will close the file handle for you. So, if you use with open file myfile.txt in whatever mode as file handle, that essentially performs the same purpose as this line here, with open as file handle. You indent the rest of it with a you indent the rest of it as if it were a while block or an if block or any other statement block, and it automatically knows to close the file handle when the file has when the fh goes out of scope. So an interesting little test here is, let's print fh, see if it exists in both contexts. There we go. So, it does still exist. Drat. Oh well, didn't work the way I had hoped. But so the with statement is another one of these Python things, like a for loop, where if it's used in a particular context, Python automatically intuits, oh, you mean to use this in this particular manner, I will help you out a little bit. So, in this case, you can think of the file handle as being scoped to the inside of the with block, and once the file handle moves outside of the scope, the file handle is automatically closed. So there you go. Although things like the string, which are read from inside of the context of the with block, are not deleted outside of the scope of it. So you're free to use it outside. Absolutely fine. You'll notice that for the rest of these slides, with blocks are preferred to just straight file openings. Because, you know, it's kind of like the for loop versus the while loop thing. With statements are more efficient for that particular function, so they are preferred, even though essentially both constructs are equivalent. If both constructs are equivalent, we prefer the shorter one, generally speaking. Yes. So, to answer your question, why don't I define fh? It is. This defines fh as fh. That does define it. It's just defined slightly differently within using a with statement. I know this is like the first time we've seen with statements. They're not particularly important for the context of this course, but, you know, here they are. So, again, you can reformat things using with blocks. They operate in the same manner, so, yeah. So that's how it goes. When you print stuff, you automatically include the end-of-line character. If you need to remove the end-of-line character from something you've read in, then you can use the rstrip method. But here's another thing, right? Here's another little piece of information to make your life easier. It turns out that file handles are iterable in the same way that lists and strings and dictionaries and all of our composite data types are. Although the file handle has more information in it, it has more stuff going on than a list, you can for loop over it as if it were that style of data structure, because, you know, well, I mean, if you want to get right down technical, if you look at the file handle class as defined in Python, they have defined the manner in which it is iterable. And for file handles in Python, it is iterable in the sense that each time you for loop over it, you get the next line. So you can for loop over the lines of a file using Python. So we can therefore remove the while loop itself for line in file handle. Then we can remove all of this stuff that continuously reads the file. And it works exactly the same way. So that's cool. In this manner, the only actual file I/O function that you actually need to invoke is, in fact, the open function, which is useful. So yeah. So with files, because we're now, we're sort of in brave new territory with respect to files, we have a special custom exception that occurs only within the context of file I/O. It's called the file not found error, and you might easily guess what this is for. If you try to open a file that does not exist in read mode, then it gives you a file not found error. And you can, of course, you can perform a try except on that error, and so handle that error if it occurs. One thing that I often like to put on tests, just test this this functionality, is I ask you if the program that you're writing fails to find the file that it's looking for, assume that the file extension was missing, and then append the file extension to the file name, try to open it again, and if that fails, then you can allow the error to propagate on down to the main level of execution. That's the type of thing I like to put in. I like to put in these types of questions. So that's more or less reading wrapped up. So let's talk about writing. Writing is our next big mode. So it turns out that files being missing only matters if the file is being read from. If you're writing to a file, then Python is sufficiently intelligent to understand that if the file doesn't exist, you probably want to create it. So with open, let's say numbers.txt in write mode now. W specifies write mode as file handle. File handle dot write some numbers. Then we execute it, and so this is a little bit tricky, but in Linux, if I hit if I type the ls command, that lists all of the files in the working directory. So if you take a look inside of this list of files that are in the working directory, this is basically the same thing as your Windows Explorer view. You'll notice that numbers.txt has been created. And if we open it in Gedit, for example, which is like Notepad, you'll see that the text that we wrote to this file has actually been written into this file. So far, so good. So we've got fewer options here than we had for reading, because whether you're writing one line at a time or you're writing all of the lines all at once, the only difference with that will be whether or not the thing that you're writing contains new line characters and is all of the stuff you want to write. Excuse me. If you want to, it's kind of entirely up to you. if you want to compose all of the lines you want to write into a single string first and then write it to the file, or if you want to feed those individually, it's entirely up to you. It's dependent on the manner in which you write your program. You can also use the print function, interestingly enough, to write stuff into a file. There's a special hidden argument for the print function where you can specify a file handle that the print function will print to, so it doesn't necessarily have to print to standard output. I wonder if you could write to standard input using print. That would be interesting. Anyway, so if you print the object, you get these separation and end handlers that, you can specify different things in different ways. Write is kind of bare bones. It expects your string to be pre-formatted. Print, you have a couple of formatting options sort of embedded within it that you can use if you like. Again, for most purposes, both of these functions will perform precisely the same thing, so you don't really have to worry too much whether you use one or the other. And of course, when you're opening something in write mode, you must always close your file when you're finished, the way that you would expect to. So, one thing, though, which is interesting about write mode, which is important to note, is when you open a file in write mode, if you do that twice, you'll actually overwrite what's already in the file. So there's a difference between write mode and append mode. So if all you want to do is add stuff to the end of a file, you want append mode. If you want to replace what's in the file with something else, then you want write. So it's more correct to think of it as an overwrite mode, right? So like if I modify this string in some way and I rerun the script, you'll notice the old information is destroyed in favor of the new information. So if you want then to open it in append mode, I believe that's with an A. We'll see. Yeah. So if you open it in with an A instead of a W, any new information which is written to the file is tacked onto the end of the file rather than deleting the entire contents of the file. Now, if you're making specific sort of surgical strike insertions of data into the file, what you essentially have to do is you have to read in the entire file, make whatever modifications you need to in Python, and then write the entire contents of that file back again. But if you're keeping something like a log file, which needs to periodically dump information into a file, then append is what you want to do. But yeah. Once again, most people have a pretty good intuitive sense of how computers read and write data, because this is how you've been dealing with data the entire time. Read permissions, write permissions, read restricted, write restricted, overwriting data, all of that kind of stuff. All of this type of mentality is the mentality you need to be able to work with files in Python. Cool. So, yep, you can use print. That's fine. You can also write directly to standard output rather than using the print method. Not sure why you would when you have print available, but you can do it. So, let's talk internet. So, when you read from the internet, the primary difference between reading a file from the internet as opposed to reading it from your local system is that you'll have a URL address rather than a file location that you'll be reading from. In general, it's the same idea as reading data from a file, except our file handle is the file handle of a remote source rather than a local file. So, in general, this is another one of these situations where we're trying to define things modularly with some degree of abstraction. Obviously, there's more going on in a file handle which has to go out onto the internet to find stuff, rather than one that is accessing something local to your system. But from the perspective of you, the user, the effect of that should be minimized to the degree that's possible. So the URL lib module, or library module, is used to open remote data sources. So if you import url.request and give it a URL and assign the if you perform URL open, which is like that's your version of open on local files, that response will be an object that contains the information that was read from the remote data source, and then you can read stuff from it in the same manner as you would a local file. One big difference, though, is that the data type of the stuff that you will get back from the internet is in bytes rather than as a string. So this is an interesting idea. When everything's working on your own local computer, your local computer knows how it interprets bytes to produce characters, right? This is the idea of a character map, right? In general, most systems around the world are going to use ASCII, or, UTF or something like that, but it's not inconceivable that you might read data from some computer server off in, Thailand or something that doesn't use the sort of universal convention for character encoding. So, if you read off that remote data source that's not ASCII encoded, and you interpret it as being ASCII, you're going to get garbage data. You're going to get gobbledygook. So, an important point in the process is to decode anything that you're reading off the internet in the in the character set that it's meant to be interpreted in. So, one of the pieces of information that you get as a response from a website is the character set that they're using. So, if you want to access that from your response packet, you go response.info.getContentCharacterSet. And if that is defined as null, then we interpret it as being ASCII. Then, if we read the response and then decode that response with the particular character set, then that will turn something that is simply binary data into correctly interpreted characters using the character set that's been specified. So let me see if we have any questions about all that. Oh my goodness, yes. So, yeah, Mark, I'm not sure if it's if it was an intentional DDoS or just an accidental DDoS. So, last semester, Mark was hosting some of the files used in Assignment 9. He was hosting those on his own local server. He runs his own server. Very, very cool. And, either people were trying to crash his server deliberately, or they'd put like a URL request inside of a loop. One or the other of those things had to have happened. So, so yeah, he kind of. So, if anybody doesn't know what a DDoS attack is, that's probably actually. Oh my gosh, the cat's just knocked something over. If you don't know what a DDoS attack is, it gets complicated quickly, but the essential idea is servers are limited in their capacity to handle requests from clients, right? So the whole model for how the internet works, in very, very general terms, is that you have computers called servers, which serve, and then you have computers called clients that make requests from servers, right? So when a client requests something from a server, the server processes that request and then sends information back to the client, and then the client, displays your web page or loads your video from YouTube or whatever it is, whatever it happens to be, right? So, it's entirely probable that most people would, in your lives so far, you've probably been dealing exclusively as a client. But you can run your own server if you want to. It's a really good thing to learn how to do, because it's a very employable skill. But why would anybody attack our servers or Mark's server? Again, yeah. As Mark describes. So the idea is, because servers are limited in their capacity to process requests, there's a queue of requests, right? So if you fill up the queue of requests, anything beyond the size of the queue is going to get lost, right? So, yeah. So, if you fill up that queue with requests, then you can essentially shut down the server's ability to deal with anything, right? And, in the modern context, we're getting better at dealing with DDoS attacks, but it's like, it's a tricky type of attack because, and it's not really, like, the purpose of a DDoS attack isn't to steal information from the server, it's to shut the server down, right? That's why it's that's what DDoS stands for. It's direct denial of service. So it's a denial of service attack. It shuts the server down. It prevents it from being able to perform its function. Now, in the case of an assignment server, if you DDoS the assignment server, if you DDoS the Jupyter server, for instance, what essentially happens is people can't get at their assignments, right? People can't even load their assignments to look at it. So, people can try to get assignment extensions that way, right? Well, see, the problem with the people who are DDoSing who were attempting to DDoS the assignments, and again, I don't know if it was intentional. It could have happened accidentally, just because somebody put like a server request inside of an infinite loop or something like that, which is totally the kind of thing that could happen accidentally. It doesn't, never assume malice when incompetence is a sufficient explanation, right? But because we have Avenue as a secondary as a secondary avenue, so to speak, for submission, it's much more difficult to DDoS avenue. Because they're not Mark, right? That it's a whole infrastructure. So they've got ways of dealing with DDoS attacks. Not to mention they just have a much higher capacity limit anyway. You always have a way to complete and fill out the assignments, even if Jupiter goes down, because of skullduggery. So, we don't really extend assignment deadlines because of these types of things anyways. So, if Jupiter is making noises like it's like if you lose connectivity with Jupiter, I highly recommend taking the code on your page and saving it somewhere else, so that if you have to redo the assignment from Avenue because Jupiter actually goes down, then you can do that. So, incidentally, I have no idea what happened over the weekend with like 1 million requests, but that would mean that each one of you would have had to make, on average, like, everyone in the class would have to make 4,000 requests for the server, on average, in one day for that to work. So I have no idea what's going on there. But probably Derek should be made aware of it. It happens. There we go. There we go. But yeah, so, so the internet, basically. You can, if you like, for loop over a response packet in the same way that you would any other file handle. It's been defined as iterable over the lines of the file that it has read, so you can access it in a very, regimented and, straightforward manner should you want to. And as opposed to a file not found error, if you try to access a URL that is invalid, you will get an HTTP error rather than a file not found error, and you can handle that using exception handling in the manner which you are well accustomed by now. So, for the remainder of this set of slides, we're going to talk about specific file formats. So, it's kind of funny, but we're kind of like all of the material about file handling has been covered, hypothetically speaking. At this point in the lecture slides, you have had access to all of the basic constructs that you need to perform file I/O. You know everything you need to know about file I/O. Everything going forward is a description of how data is stored within the context of scripts, right? So, with, various file formats on your computer have various purposes. The types of file formats that we're going to be talking about are so-called plain text formats. They're called plain text formats because if you open them up in a very basic file editor, like Gedit or Notepad or something like that, you can just read them. So if you open up a CSV file, you can just look at it and read it. If you look at a JSON file, you can just look at it and read it, although CSV files are easier to read than JSONs. And these guys are used for transferring data, typically between sort of programming languages or scripts or stuff like that. Right, right now we're kind of entering into the territory of like the programmer's territory and the way that programmers deal with data, as opposed to the sort of general user and the way the general user uses data. A general user will typically interact with data through, commercial programs like Microsoft Word or Microsoft Excel. Excel is a good example. A lot of people will confuse the program with the data, right? But a programmer has a different requirement for the data. They want the data to be in a format that is easily read by many different types of programming languages or systems. So we generally go for plain text formats such as CSV, JSON, XML, and many more, but these are the three we'll be talking about primarily. We also have a slide on HTML, which is not a programming language. But anyway, that's our lecture for today, more or less. If you have any questions, please let me know. And there you go. In computer science, JSON is a lifesaver. In data jobs or math, CSV is your best friend. XML is there. Web developers love it, but, it's kind of the joke. Here's a little bit of computer, programmer culture for you. Real programmers, quote unquote, don't consider web developers to be programmers. They, working with HTML, they don't really consider that to be programming. It's, or CSS or those types of things. You definitely do get, JavaScript is all over the internet, and I would consider JavaScript a real programming language. But, you'll see, these comics every once in a while, where it's, comics about people who think HTML is programming. But, what would HTML be? Yeah, it's a markup language. So, it's a document generation system. Yeah. Yeah, so... Alright, I'll show you something. So, when you generate a document, you don't necessarily generate that document in, okay. Going back into the history of computing, there's a difference between what's known as WYSIWYG, document generation. WYSIWYG is an acronym that stands for what you see is what you get, and, sort of more general document generation. Microsoft went Microsoft and Apple, kind of in general, went the WYSIWYG route because it's more user-friendly. You can get further with normies if you have it as WYSIWYG, right? The way that you format a Word document is the way that it prints out on your printer. But if you have something if you take a look at, I'm just pulling up my slides from a course that I made slides for last semester. My programming course in C, which you can still see on the, you can still take a look at on, it's still on my channel, the lectures for them if you're interested. It's in C programming. But if you take a look at the source file for this document, this is the source file for my set of lectures slides on, I don't even know what the topic is, but this is not what you see, what is what you get. This is a plain text file that is then compiled and turned into a PDF. The PDF that it produces is this guy. So this is what it looks like once it's been compiled. It looks pretty nice, right? It's got like comics and all kinds of stuff, right? But, you know, it looks very different if you look at it in plain text format. And obviously I couldn't present this to students, but, you know, so yeah, this is the category that HTML is in. This is similar to HTML in its design philosophy. It's meant to generate pretty-looking documents. It's not like, although you can do programming language style stuff with it, it's not really considered a programming language itself, although many of the skills you need to be able to make a document like this they overlap with the skills you need to program. But yeah. Yeah, we should update Avenue. Let me write that down, actually. Cool. Third place in Canada. Wow, that's impressive. But come on. Come on. And hey, I didn't say that it's true that web developers aren't real programmers. I just said that's the prevailing attitude. Yeah. 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 Latex. Yes. Yeah. Yeah, I vastly prefer this to PowerPoint. Like, it's, believe it or not, it's much, much easier to, like, part of the thing I find about PowerPoint is it just, like, it thinks that it's appropriate to vary the size of the font in order to fill the page. Whereas if you take LaTex's approach, LaTeX modifies the spacing between, like, these bullet points in order to fill the page, which is a much, much better, you get a much more clean, consistent looking slide deck if you use that approach. It's just, it's so good. It's so good! I love it, so good! It looks like $1 million! That's what I think. But anyway, yeah. For those who think web devs, I'm trusting you, Mark, that this is fine. Oh, the Twitters. Ah, there he is. Yeah. So, hopefully you appreciate Mark, because he's pretty good at stuff. I pretty much knew I wanted to hire him as a TA when he started submitting bug reports for the assignments that we were distributing. I was like, yeah. Anyway, I'll let you guys get to your classes. Thank you very much. No more hints about the test will be dropped during this stream. So you can all log off now. Take her easy, folks.